Voila. So thank you so much for this nice introduction. And thank you, Renee, for inviting me. I'm very honored, actually. And I decided to use this opportunity to share some personal stories with you. I never do that, but I chose this intimate location to do it. You see here a picture that you will see again and again from different perspectives, this is from space, but I also have some in situ information to share with you. So I'm going to talk about bridging the gap between science and innovation towards societal transformation, and the challenge is, how do we actually transform all the data and all the knowledge we have into something, an impact for society. And I will tell this story with a perspective, a gendered perspective. I am, as you might see, a woman, and I will simply say men and women in this context. Now, I will my talk will be in 3 parts. I will start with the beginning. I will then go to talk about the bridge, and finally, the humans. And what you see here is the 4-year-old version of me, by the way, and I was already on the phone. If maybe you are so young, so you don't recognize that this is actually a phone. It was a plastic phone. So, how did it all start? You see here the heart of the Milky Way. In fact, this meant something special for me because I grew up in the countryside, on the countryside in Norway. And I grew up in the 60s and 70s. And back then, in the countryside, it was really very dispersed, farms and houses. It was not even a village. Here in Europe, first time I went to Europe, I was surprised that all the houses were gathered together, even though there was lots of space. This was very different types of organizing human activities. So I grew up in the countryside with lots of space, and we didn't have kindergarten either. So as a 4-year-old even, and throughout my childhood, we were let outside to play without any adult supervision, no helmets, no security when going out in boats. I grew up by the lake. We were left to explore. And one of the things, when we had some times to get back home, indoors in the afternoon, in the evening, and as we have 4 seasons in Norway, very distinct seasons, and when the fall comes, the days become shorter and shorter, so we had to come in sooner. And I still to this day have a discussion with my mother when it's actually dark, because when you're outside, the dark is not so early dark. When you're inside, it looks darker. But this phenomena made me, as a child, look up at the stars. And in the 60s and the 70s, there were no light pollution. So we could very clearly see the night sky. We could even see the Milky Way, not as sharp as the James Webb telescope can do, of course, but we clearly saw the Milky Way, the belt of the Milky Way on the sky. And that made me think and wonder. And it's nothing unique with me thinking and wonder, because I think we all can recognize that as children, as we are going from being a child to an adult, we discover first, this is my hand. As a baby, you discover this, this is me. And then you get a picture of, this is I'm a person. And then you see, I'm a person in a family. And then you see, you are a person when my family is in a local community. Then you see the country, and then you see you're part of the planet, and you start to think about, I'm a part of the universe as well. I think this is a universal development all of us can recognize, more or less. And the only difference maybe for me and many of the others is that I could not let it go. Why, to wonder about the place, the stars, what is the universe? I'm telling this story because that is the only reason I'm standing here today. I was so curious, I was so obsessed with understanding the universe. And so I became an astrophysicist. It was not an easy transformation going from this little village or the countryside to the big city. Oslo is not a big city globally, of course, but it's the capital of Norway. And I think that even though it's not a very long distance between where I grew up and the city of Oslo, it's probably the biggest change, the biggest bridge I have crossed in terms of cultural shock. My family, namely, was not an academic family. Neither was the community around me. In fact, we saw academics as kind of lazy people. So it was not like something you would strive for. So I went against my family and my local community, and I went to the university. And at the university, I didn't feel exactly welcome. And specifically, it was challenging to come into the Institute of Theoretical Astrophysics. And I think this is something, my story here illustrates that there are some challenges that we have to overcome, maybe specifically women coming into fields that is normally not regarded as something good for a woman to do or a girl to do. I will summarize my time at the Institute of Theoretical Astrophysics, and I'll let you think about this statement. Theoretical astrophysics is ridiculously easy. I learned so much about the universe and making these bridges. So that is the start. That's why I'm here. And I think it's not quite unique. But now I'm going to talk a little bit about my father and twins, and come back to what Zoe was talking about. I'm using the human factor here. I'm focusing on the humans here. You see here, my father is an identical twin. And when they were small, my uncle and my father, even smaller than this, the parents had trouble seeing who was who. They had to tag them. But the difference between the human twin, the identical twins, and digital twins, I will explain to you. Now, as the identical twins grow older, they become more different. So eventually you could see that there were two different individuals. But opposed to digital twins, they actually, as they grow older, they become more alike. And this is now a pipeline. Suddenly jump to the technology here. If you work with data and transforming data, you will recognize this structure, of course. You start to collect data, and then you have to store it somewhere and prepare it before you run some models and transform it into new information using analytics, artificial intelligence, machine learning, etc. And then you have actions and interactions coming out of that, visualization and access to the new information. Now, this is recognizable. What is unique with the twin, and here is why twins become more alike, the digital twin becomes more alike the real world, is that you do this repeatedly. It's a feedback loop that will increasingly and gradually improve the replica, the digital replica of the twin. And what does the twin, why do we care about digital twins? It's very, very simply said, it's a replica, a digital replica of the Earth, and it provides us with information about what is happening now, what can we expect next, and then, of course, the what-if scenarios. We can also include in the twin what happened in the past. So historical information is also valuable in digital twins. And when we are talking about the specific digital twin of the ocean, there is also other information that needs to go into it if you want, so economic data, social data, etc. So you really build in a lot of information in this digital replica. There have been definitions developed over the few years that I've been involved in it. And here you see a couple of definitions. I like standards and best practices. And you see the top one here is the one that is the International Standardization Organization has landed on. So digital twin is a digital representation of a target entity with data connections that enables the convergence between the physical and digital state at an appropriate rate of synchronization. And I'm saying, some think that it needs to be real-time data or near real-time data. But even when you say that, what exactly do we mean? I was working with GPS, that's sub-seconds, that's real-time. Some is like 1 second, one is 10 seconds. What exactly do you mean with real-time and near real-time? But not only that, the digital twin can also be very useful if you have longer time perspective. It gives you a very good overview of the situation in an integral way that we have not developed so far. And I'm not alone of liking digital twins. You may recognize this man. He was stating that digital twins is genius. The concept of digital twin is genius. He was saying this in connection with the UN Ocean Conference a couple of days ago, last week I think it was. And I like the sound. It sounds better in French. C'est génial. I think that's it really gives you the emotion of better in any other language I know. So Emmanuel Macron, he thinks that digital twins is very useful and valuable. And big congratulations, by the way, to the French communities who have succeeded in reaching the ears to the top politicians. I think this is an important part of actually transforming data and knowledge to societal impact. We need the politicians to really embrace these new tools and technologies that we have. Now, Zoe mentioned that the plan was to develop local and thematic twins. Now, it so happens that the European Commission already have funded some work in that direction. The Iliad Digital Twin of the Ocean project actually is an innovation project, meaning that it is going a step further than the research and innovation project. It's more towards closer to operational services. So that's one thing, and we have worked on that for 3 years. And we looked at the digital twin of the ocean from a human perspective, from an activity perspective. Because if you want to use the information, it will be related to concrete problems. And the problems are related to human activities. So we divided this different types, 12 different types of activities related to the ocean. And so jellyfish swarm forecast is one of the themes, oil spill simulation, plastic pollution monitoring, fisheries and sustainable aquaculture, marine and maritime insurance, aquaculture water quality and ship traffic, coastal sediment transport, ocean energy potential, met, hind, and now forecast, which is closer to what the digital twin ocean, the European digital twin ocean, is providing, like a huge capacity for that type of twins, ballast, water monitoring, and harbor safety, and existing wind farm capacity. I'm reading all of these thematic areas so that you really get a feeling how diverse our activities are and how diverse data and information that we need to include in order to solve the problems. And interoperability of all this is key. So we need to bridge this science and innovation to human activities, and I already covered basically why digital twins is important, because it's leverage the big data, artificial intelligence, and advanced analytics to create these virtual models that can improve various societal sectors. And the concept, by the way, of digital twins is nothing new. It's an old concept. The reason why we talk about it now, I think, is because we have so much data, so much digital data that we didn't used to have. And the technology to combine it is also here now that we didn't have before. So suddenly we have this huge capacity to use, to create digital twins. So, but it's complicated. This is now the picture you see here is the world's strongest maelstrom. And the bridge I showed you before, I forgot to tell you, that's actually the bridge across this maelstrom. And it was on the satellite image I showed you. I will show you the locations of it later. Now, you will recognize on the top here, you collect the data, you transform, you prepare it, you transform it, and then you you present it to the end user. And you see that we have so many different types of data in the column of data collection, all from satellites to at the bottom of the sea, and even the interior of the Earth for that matter. And all of these processes that needs to be done requires interoperability, requires that we are able to combine in a meaningful way that gives us the right image of what the reality is based on these digital processes. So we need to harmonize, we need to use standards, and this is, of course, IEEE is a standardization organization, so you know this, how important it is. And then we also need to have best practices, because across all these different twins, we learn we have different experiences that we can share with others, not necessarily within your sectoral or thematic twin, but it actually can be shared across the different thematic areas. So, this does not happen by itself, obviously. And who is doing it? It's the humans. And the humans, they have, in this pipeline of harmonization and transformation, the humans have different roles and responsibilities, and they come from different cultures, they speak different languages, and that's what is really necessary in order to be able to transform those technology, the data, into something meaningful, useful for the community. It needs to activate and engage all the different types of actors. And some of these actors are women. And we need to include that perspective. I will come back to that. I will come to that soon. But you see here in the co-design and co-creation is very popular to talk about. But what is missing is that we don't spend enough time. We don't really appreciate the effort that goes into co-create. We need to overcome different cultural barriers because politicians or policymakers like Zoe, for instance, will not necessarily have the same knowledge as a data computer scientist, and she's not meant to, but they need to be able to speak to each other. And in order to facilitate that that communication, you need to spend some time, because there will be misunderstandings. There will be, even in sometimes, it will be conflicts of interest. And you see here this picture, again, this is the in situ image from the satellite image I showed you. And here you see human activities related to the ocean. We have an aquaculture activity, we have fisheries, a lot of fishing. This is a very popular fishing place. Tourism, it's a beautiful area, so tourists are here. And we have nature reserves, because it's a precious, beautiful nature. And all of these interests needs to be combined. And when you are a politician, how do you actually take the best decisions to secure the interest for each of these types of activities? This is what the digital twins are able to do, but it requires that those stakeholders, those who have interest in aquaculture, in fisheries, etc., they have some of the common interest of having the knowledge, but there also is the conflict of interest. So typically the aquaculture is not so good necessarily for natural wild fish, and this will be detrimental for the fisheries, etc. There are different aspects that you need to consider, and the digital twins will actually help you in making the best evaluation and decisions for an area. This is the potential. Now, there are humans, as I said, and there are women in this process as well. And so having the gender perspectives is twofold. First of all, the women's interest is, of course, we need to also take into account half of the population's interest, but also there are specific experiences and knowledge that can be different, that are different. Just the fact that women are carrying babies and giving birth to new humans is like fundamentally different from men's experiences. So just that in itself, it's an example of the different experiences that can come into, that needs to be factored in when you are developing solutions for society. And yes, artificial intelligence. You know, a digital twin is using artificial intelligence. And when we are doing that, we are based that on language models. The language models is getting information from different locations and different documents, etc. And in these documents, if you do the analysis and many years back, you will see that there are certain associations between men and women that are different. And this can be enhanced or give the wrong impression in the artificial intelligence models that we are using. So, for instance, they found, this is the Gendered Innovation. I recommend you go and visit that website. It's a collaboration between the Stanford University and the European Commission at a high level, and has been done for many, many years. I show you here the artificial intelligence example, and here is me in the boat. And the boat and woman actually is true, but not necessarily captured over the time in language models. So, and this, we have to pay attention to this if we want to be representing the world correctly. Another, for engineers, I assume there's lots of engineers in this room, is a more technical, practical thing here is the crash dummy. And in the beginning, when the car factories producer were testing for security, they were using like the standard dummy with like an average measure from typically a man. They did not take into account that women, as I said, from time to time carry babies in their stomach, and they are also traveling with cars. And so they needed to use a dummy that had those features included in order to create the safest way of traveling. And I will, you see here a citation from yesterday. We had a workshop on interoperability yesterday, and Malcolm Heron, I don't know if you're in the room, I'm loosely referring to what you said, namely that humans do not necessarily make rational decisions. We are humans, we come with a bias, and this is something whether or not we fight against it, it will be carrying, our experiences, our culture, our interests, etc. So this needs to be factored in also when we are creating these digital twins. So, I don't know how you are seeing, the capacity to and knowledge we possess in society and science, technology, engineering, and mathematics. Where I come from, this is like something that is discussed all the time, that we need more of this competence. Yet, at the same time, it's not enough people in general making this education, which is so strange to me, because we are getting more and more reliant on technology demanding this kind of competence. It's sort of it's a puzzle to me why this is why it is a problem. It might be connected to the fact that in a social context, a random social context, and you reveal that you are not very good in mathematics or physics, and it's sort of like looked at as something, a virtue. It's like, I don't know any math or physics, I'm so stupid in that. And that's perfectly socially accepted and even considered charming and cute. While if you are revealing that, I don't know exactly who is the president in the United States again? I mean, you will be like, who are you? Why? How can you be so stupid? You're just a very extreme example, of course, but it's in the society that I know, in the Western society, I think this is the case. And maybe it's related to that we have to be more proud, and we have to work to make these fields more, that you should be ashamed if you don't know the basics in mathematics and physics. Maybe a little bit extreme, but and I will also say that we should also normalize that interest in mathematics and physics, the STEM, is perfectly okay. Here I show you, when we are children, I find this is a very limited group of people that I'm basing my conclusion on here, but I'm coming back to my family and to where I grew up. These pipes, by the way, is something my father bought from a cellulose, factory. For some reason, I asked him just before coming here why. He said it might come in handy. So that's the kind of father I have. This can be used for various engineering purposes. Now, you see here my grandchildren play, and you see both the boy and the girl, they are equally inquisitory. They were just left there exploring these pipes. And it shows that when we are young, I think we are all more or less exploratory, and there is no difference between men and women in that sense. But for some reason, something happens, and it becomes less attractive for women to do the STEM education. And I think we have to, in order to solve this, also for digital twins, we need to normalize that women or girls are equally interested in science and technology as the boys. We have to not tell them the stories that, oh, this is a typical boy, this is a typical girl, because when they are left alone to explore, everything is normal, both for girls and boys. So, in conclusion, I would say that in this group, where we have talked so much about the technology and the interoperability on the technical side, I think I will also use this opportunity to say we need to talk. We need to talk across the different disciplines. We need to spend resources and time on this process, on the process of talking, and get to know each other and overcome misunderstandings across disciplines, across cultures. It requires time, and I think that in the future, funding of projects to develop further digital twins, to further develop the use of new technology, we need to put in that factor in our budgets, both the funders and those who are planning their projects. So we need to talk. And here you see the circles to see where you have seen the in situ images. And I think that also I will say that satellite imagery and local observations are equally important in order to create digital twins. Thank you very much.